Hello, everyone. Thank you very much for joining this hopefully quick talk. Uh, we want to talk about how secure microservices without traditional firewalls. My name is Petr McAllister. I'm implementation engineer of a company called TwoParty. We're mostly working on service mesh and implementations in enterprise environment. And it's difficult to start talking about it, and I know I have a limited amount of time just about VPN. We want to cover a little bit how we got here, how service mesh helps us with microservices, and cover network aspects. And this presentation actually was originally delivered by my colleague, founder engineer of TwoParty. His name is Ignacy Barrera, and I'm just repeating basically what he said in his presentation, hopefully adding a little bit more context because he did his while ago. So, and how we got here? Obviously, a little bit of history. We had one application delivering information from application to user, and application was facing internet. We had firewall. Firewall said, okay, with port, with IP, allow access. Everything else be closed. Then application grown and grown, and we had more ports open, more services delivered to the customer, and we decided, our consumer, and then we decided, okay, let's break it to microservices or services at least. So let's have it on multiple computers, servers, and now we cannot only separate between external network and internal network. We also need to separate, use additional firewalls, use DMZs or something to separate different parts of application from each other, and say only service A can talk to service B on such and such port from such and such IP, etc. And to add complexity here, we actually moved it all to the cloud, and the cloud had kind of similar concept, but now you're getting VPCs, you're getting different subnets, so it gets more complex. You also get security groups, not only firewall groups, so you can do more granular separation of your rights and services, right? And when we were in a cloud, we decided, why don't we break application even in more parts? And instead of having EC2 instances or other cloud instances, let's run our application as function or microservices. And everything on a design board looked absolutely awesome. And everything looked absolutely awesome until some application or some service experienced some kind of failure. And obviously, there's so many scenarios how it can affect other pieces of application, and some of them we tested, some of them we didn't test. Something in our specific failure went different ways than what we tested, and now we have multiple services affected by one single failure of application. So it's maybe not complete downtime, but maybe it's slowed down, maybe there's some delays, and somehow we need to deal with it. So there's multiple projects that come in play. Some of them open source projects, other projects came from established enterprises and companies. So to name a couple of them, Skywalking is a project that grown up in Asia and basically allows you to aggregate metrics, and instead of collecting everything on every node, get more holistic view what's going on in your application or in your piece of cloud. Zipkin, different approach here. So basically put additional header in your packet and trace it all the way down. So you have one big trace that shows you all hops and where you have delays, where you have different performance issues. So when we think about all these different projects and what they exactly achieve, it basically comes to several different aspects. First, we need ability to discover services. So every time when you run service in the cloud, it can get different identity, different IP, maybe even a different region or zone that's going to be running. So we need to have some inventory where we can say, okay, service A calling service B, and service B is running here and here and here. So also, if something happens to my service, we need to be able to somehow deal with the error. So move load somewhere else, spin up additional instances, etc. If our application is too busy, we also should be able to just stop traffic running, going to this specific instance of the service. So this instance can recover from extra load, extra requests that we didn't expect this specific service would get. And also back pressure and tracing, I kind of already described this. So then we come up with the idea that we need applications or services that know about all these things, all additional services, all additional workloads, and can adapt to it. So it's kind of self-healing, self-discovering services. And it came up in multiple different form factors. And in one environment, you can see all of them. You can see Java and Node run different services of the same application. So now in every specific implementation, you need to implement, to introduce these pillars that allow you to function correctly. And it can be a little bit difficult to ask developers and expect them to implement the same functionality in all different applications, even using libraries, because you need specific libraries for every type of code. So if we kind of take a step back and look how we originally delivered, so don't get confused here with envelopes. We're talking about packets from node A accessing being delivered to node B. So we had this problem many years ago with introduction of basic networking. We needed data to get from point A to point B. And we come up basically with two different models. They have the same meaning behind them, but a little bit different. So in general, you have these different layers, and your application doesn't really know what's happening on your physical layer, right? So you have some kind of drivers and other things on different layers that take care of it and make sure your zeros and one on your wire delivered correctly and free of errors. Now it seems we're hitting exactly the same issue, but on higher levels. So we have applications that needs to make sure all the things that we already discussed are there. So we can trace, we can get metrics, we can understand when other end of application is to load it, when traffic needs to be redirected somewhere else. So everything here is the same, but now we just kind of increase our attention and looking at application level. So same problem again, non-application level. So, and here in the play, service mesh comes. And service mesh delivers exactly what we already discussed. So consistency, so instead of having different libraries for different pieces of your application, service mesh provides this identical approach to all of them pieces. It provides it from outside, and it's centrally managed. So you don't have to go on every service and configure it. You describe your rules, permissions, policies, and they get propagated across all your fleet. And of course, it needs to be very adaptive to the changes. So you cannot really redeploy your application every time when there's some changes happening of how you want to monitor, secure, or trace your application. So 3 pillars of service mesh: networking, observability, and security. So we make sure traffic is going in the right direction. We have tools to monitor how traffic is going, and we make sure there's only traffic that needs to be served is served. And idea here is to take it away from developers. So it's not developers who's taking care of it. It's a service mesh that takes care of these specific aspects of your application, and developers can concentrate on what they should be doing, applications that delivers value to your business. At TwoParty, we very closely work with Envoy open source project and Istio open source project, and you can read more about what exactly Envoy is doing. What I'm covering here is mostly focused on Envoy, but I can assure you that all other service meshes deliver similar experience and similar concepts. And if you're looking at control plane, so there's a different mechanisms that can deliver it, but again, control plane makes sure you do all configuration in central place, and it gets delivered to all your microservices at the same time. If there's any changes propagated everywhere at the same time from the same source of truth or central location. If you look at on traffic aspect of service mesh, what's happening there, we basically can say how much traffic going in different directions. It's very helpful if you do canaries deployment. So some people call it green, blue, different A, B, whatever. But idea is you have new version of your application. You want slowly migrate traffic there. You don't really need to configure anything on different layers. You just tell your ingress and your proxies sidecars how to deliver it. And I kind of missed covering it, but a service mesh idea, you have Envoy that runs on every pod, Envoy or Istio proxy sidecar that runs on every pod and kind of fronts your application, your service, right? So service only talks to Envoy proxy, and Envoy proxy talks to external world. And two services, they both talk to Envoy proxies. So service A uses its proxy to reach proxy on service B, and service B proxy talks to service B. So in this specific case, we just say, okay, for this specific service, so much should be going to version 1 and so much going to version 2. And we don't really need to do anything. So if you go to Kubernetes, you need to deploy so many instances of each service. Here, proxy is smart enough to understand how traffic is delivered and allow you to do that. It's not only aspect that service mesh is doing. We also are providing resiliency, so you can specify if service A is not responding, try it again so many times with an interval of so many seconds. Or you can also figure out if there's some anomaly in your behavior of your fleet of services, and if we call it outlier detection, and basically exclude the service from circulation. Also, if some services are very busy, the circuit breakers, that deliver ability to stop traffic going to these busy nodes or busy services. Also, if you're testing application, it's shown here in the middle of the screen, you want to say, I want so many failures included in my traffic, and see how your application responds. So it's main aspects of traffic management. And next aspect is observability or telemetry. And the best thing here that you should understand is consistency. So Because again, it's not multiple libraries at the same proxy fronting every service. It collects metrics in exactly the same way, uses exactly the same language, uses exactly the same measurement units, and all of it delivered to the central plane where it's all aggregated, and managers of the system can understand better how traffic works. Moving to security and aspects of security. So service mesh allows you to set up certificates on for every service. And this certificate in Envoy we use SPiffy, includes your identity of the service. So it allows to create rules saying service A only can talk to service B, it cannot talk to service C, and set up any rules that fit your organization to make this very, very controlled way of delivering specific information to specific service. So make it really microservice specific, what information available to who. And with SPiffy certificates, they sign certificates, and they have inside of the certificate they have service identity. So no one else can claim I'm service A. Only service A can claim it because it has proper key, proper certificate. At the same time, even we have this identity, there is a concern that if traffic going in open text, someone can listen to it, someone can capture it, someone can steal confidential data being transferred between microservices. And here we come to two different concepts. SPiffy I kind of covered already, so a little bit more details here. So it's X509 certificate, and it has identity. Another thing we can do here, we can use encryption when traffic goes from one side to another side. And for encryption, we use something called MTLS. So MTLS is basically mutual TLS authentication. So it means in a normal world, you go to PayPal and PayPal tells you, okay, my certificate is valid, you can do business with me. MTLS, it's a little bit different. So MTLS, you as a user also need to present certificate saying, I'm your user, PayPal, and you can deal with me. I'm not some hacker from somewhere you've never been to, right? So it's I'm valid party for you. So it's what MTLS is. And again, using proxies here, we are able to exchange with certificates and do encryption using them. And with encryption is only available if mutual trust exists. So it brings us to basically core of my presentation and topics that we wanted to cover the most. So you have microservices running in Google and some developers trying it on AWS. Let's say you have development shop because of cost hosted in GCP and production in AWS. So in traditional world, you create VPN. You create VPN between your on-premise, AWS, GCP, and you have to set up certificates, rotate certificates, make sure you trust with specific networks. It's a lot of work and a lot of troubleshooting, and we all know sometimes it breaks. And now you have also console that administrator wants to access all these services or do some testing to provide if you want to do some on-premise testing to your clouds. And now you need to set up extra certificate and do extra stuff. And all it's very dynamic and it changes all the time. And you need to have some platform to keep it all together. So idea that I just explained, idea of two parties having certificate and they fronting microservices and they rotate it on permanent basis can be applied here. Basically, we don't need VPN anymore. We can use, and I know it's kind of very bold statement, but it's what I'm working with enterprise customers and it's what we see every day. We don't really need this specific approach here. We don't need VPN anymore. We can just do everything using a certificate that issued to the services because services must trust each other and to communicate with each other. And these services can be in any cloud, it may be multiple services, they can have different IP addresses. It doesn't matter anymore because in front of them they have proxy and proxy have automatically issued rotated certificate. And you can set up in service mesh rules who can talk to you based on your application values, based on your services, not based on specific regions or IP addresses. So from me as a networking guy and security guy moving to ServiceNow Space, it sounds mind-blowing and almost impossible to understand because we were building VPN for so many years and now we don't really need it. So I'm running out of time. There's a little bit of coverage what different parts of service mesh provide. And I think we covered all of it. And only additional thing I wanted to say here that I'm really asking everyone who's interested in the project to go on these websites and links and see if they can contribute. And it doesn't matter what you can contribute. You can do some demo, you can write some documentation, you can write some piece of code. These projects really needs contribution and contribution, especially for audience like BSides Vancouver, audience that really focuses on security. And just to mention one more time, that original talk was provided by our engineer Ignacy Barrera, and basically I just did a recap of it here. Thank you very much, and hopefully you were able to learn something new in this short period of time.